Picture this, the year is 2026. While a lot of us are still, scrolling through our feeds, debating what an AI chatbot should or shouldn't say, there is a massive, quiet transformation happening right now in the East. It looks way less like a simple tech upgrade and a lot more like the dawn of an entirely new era. Because the future of robotics isn't just on the horizon anymore. It has already quite literally walked through the front door. So I want you to ask yourself a question and really visualize this scenario. What happens when a 500-kilogram steel behemoth, we're talking almost 10 feet tall, winds up and just punches straight through a solid concrete wall? You might be thinking that sounds exactly like the climax of a sci-fi blockbuster, but listen to this quote with me. Imagine a 500-kilogram steel behemoth folding its limbs to become a high-speed vehicle. This isn't a scene from a Hollywood blockbuster. This is reality in Hangzhou. We are talking about the transforming GD01 Mecha. And guys, this isn't some CGI concept rendering. It is an objective, production-ready piece of hardware. Just look at this headline for a moment from the South China Morning Post. This is the news behind today's video. Real-life transformers. China's Unitree debuts a mecha robot that shifts from 2 legs to 4. The GD01 expands the Hangzhou-based company's portfolio at a time when Chinese manufacturers are significantly outstripping their US rivals. With that said, let's go straight to the intro. The algorithm buries channels that show the truth like mine every single day. The only thing that fights back is you. 1 like, 1 subscribe, turn on the bell icon. That's how the truth about China survives on YouTube. Don't let it disappear. Thank you very much. The era of the robot has officially arrived. Because while Western headlines are totally saturated with debates about high-margin software and the limits of large language models, China is actively deploying a literal humanoid army. They are already running what they call dark factories. These are massive manufacturing hubs where the lights just stay completely off because the workers navigating the floor are made entirely of silicon and steel. Okay, let's dive into this. Part 1. The mission. Uncovering steel. Our mission for this explainer is to conduct an urgent, totally impartial investigation into the data, the policies, and the incredible engineering driving this robotic revolution. And everything begins with this one core concept: embodied intelligence. This is the beating heart of China's technological strategy. It's the idea that artificial intelligence shouldn't just be isolated in a computer brain to write emails or generate code. Instead, high-end AI must be integrated into physical robotic bodies. It's a massive pivot from abstract software to physical steel that can walk, work, build, and interact with the rough, messy real world. Moving right along. Part 2. Blueprint, the 15th five-year plan. Now, what's really interesting about this slide is the sheer staggering scale of adoption we're seeing. To understand how they're pulling this off, we have to look at the blueprint behind it. The 15th five-year plan, covering the years 2026 to 2030, is a massive whole-of-country strategy, prioritizing physical AI to sustain economic growth. Just look at these numbers. In 2024, China alone accounted for a mind-blowing 54% of all global industrial robot installations. The entire rest of the world combined makes up the other 46%. They are consuming and deploying robotics at a pace that is frankly hard to wrap your head around. Let's ground this dramatic narrative in some hard objective data sourced directly from the 2026 Steel Dragon report. As you can see, China currently boasts an operational robot stockpile of over 2 million units. To really put that into perspective, their closest competitor, Japan, has about 444,000 units. That means China's active robotic stockpile is 4.5 times larger than the global runner-up. This leads to a massive divergence in global strategy. It's fascinating to see the contrast. The traditional Western approach largely keeps beautiful, highly advanced prototypes confined to pristine laboratories, heavily focused on the software side. But the Chinese approach prioritizes mass production and early deployment into harsh, extreme real-world conditions: dust, intense heat, uneven terrain. The robots break, the engineers iterate, and they redeploy. This fast feedback loop creates a massive self-reinforcing data advantage that is practically unmatched right now. Alright, part 3. Hardware, the transforming mecha. Let's look at how these policies physically manifest into hardware, specifically focusing on a powerhouse out of Hangzhou called Unitree Robotics. $16,000. I really want you to let that price point sink in for a second. That is the starting cost of the Unitree G1 humanoid robot, a machine capable of complex human kinematics, running, and physical tasks. This emphasizes a truly critical point. We are no longer looking at multi-million-dollar lab demos. We are looking at aggressive, highly scalable mass production. But Unitree didn't even stop at standard humanoids. Consider the GD01 civilian mecha. This machine weighs 500 kilograms and stands 2.8 meters tall. It's got 23 degrees of freedom, framed entirely in aerospace-grade aluminum. The pilot actually sits in a torso-mounted cockpit controlling it via joysticks, or teleoperating it through an Apple Vision Pro. And the craziest part? It can transform its chassis from an upright humanoid into a highly stable quadruped. Plus, it uses vision language action models so the AI can actually understand physical common sense to assist the human pilot. And the cost for this man-transforming mecha is $650,000. Now, obviously, that is a ton of money, but in the world of high-end robotics, it is actually a massive disruption. Just for some context, boutique foreign competitors like the Japanese Tsubame Arcax launched at around $3 million. At a fraction of that cost, the GD01 is absolutely signaling the true dawn of the commercially available civilian mecha. So the crucial point is part 4, the data, supply chain dominance. How are they doing this so cheaply and efficiently? Well, the secret lies in almost complete supply chain dominance. For decades, the world relied on Europe and Japan for precision gears and servo motors, the literal joints and muscles of these robots. Not anymore. Chinese firms have successfully decoupled from that and are now producing roughly 80% of their components totally in-house, and their real trump card? Rare earths. China controls about 90% of the processing capacity for neodymium, which is absolutely required to make the powerful magnets inside these robotic actuators. This intense vertical integration allows for a manufacturing cadence that honestly feels like science fiction. Which brings us to part 5, next steps, the robot dividend. You may be wondering, why the immense rush to build an army of steel? The answer lies in a severe demographic crisis. The state-mandated master plan is clear. Step 1, deploy embodied AI into unstructured environments. Step 2, establish fast feedback loops by putting robots into hazardous frontline work, like disaster rescue and power inspection. And Step 3, cultivate a robot dividend. Because China's working-age population is shrinking, they view automation not as a threat to jobs, but as an absolute existential necessity for societal survival. That is exactly why public trust in these machines is incredibly high over there. And the math completely backs up the strategy. Studies show that a 1% increase in robot density in China leads to nearly a 1% gain in overall manufacturing productivity. It's practically a 1-to-1 correlation. We are already seeing the sheer scale of this with initiatives like the State Grid Corporation's $1 billion plan to deploy a humanoid army for grid maintenance. They are rapidly locking in their economic resilience for the future. And this brilliantly illustrates what analysts are now calling the robot deficit. While Western markets focus intently on the software side, China has mastered the gritty, hard work of manufacturing and industrial scaling. They now have nearly 100 dedicated robotics majors across their universities. They are actively training a massive industrial army of engineers whose sole focus is bringing these machines to life. Part 6, conclusion. The dragon awakes. To sum all this up, the trajectory we're on is undeniable. From synchronized humanoids at the Lunar New Year Gala to 500-kilogram manned mechas patrolling industrial zones, the era of the robot is already being mass-produced. So I want to leave you with one final provocative thought to linger on. Given the specs we just looked at today and the reality of this rapidly approaching future, if you had the keys, would you pilot a transforming mecha to work? Don't forget to drop your ideas for what complex topic we should unravel next. I'll see you in the next one. Zaijian.